So if the gradient is 0 for the tangent line, it means that its normal line is going to be a vertical line. The gradient is the slope. And so the slope for a vertical line is undefined. It's not 0, but it's undefined. So that all we have now is y is equal to mx plus c. Now, since m is 0, we'll have 0x plus c. So that at a point 0, cos 1, our tangent equation is going to be y is equal to cos 1. This is called a horizontal line. So we have found the equation of the tangent line. It's tangent indeed, but it's just a constant line function. This was 1D. So let's go to question 2. Question 2. The tangent line to the curve.
Can you go back the previous quote?
Also, the literature that's out there. I think there's a lot of graph example. Just going to so that's one of the things I've seen in most. But if you go that direction,
Okay, sir, thank you.
Okay. So I go to question 2. The line, so given the equation y is ln ax plus b. The tangent line to this curve at the point 5, ln 5 is parallel to the line 8y is equal to, 8y minus 2x is equal to 15. What's the question? Find the values of a and b. The tangent line to the curve is parallel to the given line. So one thing we understand is that when you are told that two lines are parallel, it means that they are of this nature. Okay, they will never meet. Now, the only way two lines can never meet is when their slope is the same. Because if the slope changes, if the slope is different, then one day, no matter how long it takes, they will meet. But when the slope is the same, they will never meet. This means that the gradient of this line is the same as the gradient of this line. So the tangent line to this curve, which is parallel to this line, has the same gradient as this line. So from this line, we are getting the gradient by differentiating it. So if we differentiate 8y, we get 8 dy dx. We differentiate 2x, we get 2. Differentiate 15, we get 0. Then we solve for dy dx. This is going to be 2 over 8, which is 1 over 4. So we have found the gradient of the tangent line is 1 over 4. So because we have it there, we are also given that the curve passes through this point. For a curve to pass through a point, it must satisfy the point. Meaning, when you take x to be 5, when you take x to be 5, y is going to be ln 5. So we are going to have ln 5 is equal to ln, where there is x, we'll put 5, plus b to the power anyway in the square root, like that. Now, when you have such a relationship, for ln A is equal to ln B is exactly ln A is equal to ln B implies that A is equal to B. This is the only way those two can be the same. Okay, here we just use simple logic. For example, if you are given m a x b is equal to m a y b, you don't need to be told that x is equal to y. That's the only way two things can be equal. It means that where it seems like there's a difference, we're going to get that same suspect and make them be equal for us to sort out any complications. So if you have ln A is equal to ln B, it automatically means that A is equal to B. Properties of logarithms. Why? Mathematically, we are saying ln A, you can bring ln B the other side, you get 0. If you are subtracting the same base, you divide 0. But this means that you are dealing with log to the base e. A over B is equal to 0. You raise e to the power 0 for you to get A over B. But a number to the power 0 is 1, which is A over B, implying that A is equal to B. I've showed now mathematically. So when we come here, we'll say 5 is then equal to root 5a plus b. So that if we square both sides, we'll have 25 is equal to 5a plus b. So we have this equation 1. This equation 1 is waiting for another equation that will help we get the values of a and b. So where do you find the other equation? Since we say that the first derivative of any function is a gradient function, and we have the gradient of this line. Okay. We have a gradient of a tangent line to this curve at this point. Meaning, when we differentiate y, how do you differentiate ln? If you are given ln u and you are differentiating, its derivative is just to differentiate u and then you divide by u. It means you are done. So in our case, we'll let u to be ax plus b to the power half. So that u prime becomes half ax plus b to the power negative half, and then we multiply by a. If we simplify this, I'll simplify it here. It is a over 2 to the square root of ax plus b. So that we divide this by root ax plus b over 1, of course, which is a over 2 root ax plus b multiplied by root ax plus b. This is the same as a over 2 ax plus b. So we already know what this is. It is the same as 1 over 4. They are only equal if x is 5, meaning at that point. So in y prime, where there is x, you put 5, you are going to get 1 over 4, implying that we have a over 2 a by 5 plus b is giving us 1 over 4. So 4a is equal to 2 5a plus b. If we cross multiply, divide by 2, divide by 2, you get a is equal to 5. We get 2a is equal to 5a plus b. What does this mean? This means that b is equal to negative 3a. If we take this the other side. Now, if you come to this equation here, equation 1, and get the value of b to be negative 3a, what are we going to have? We're going to have 25 is equal to positive 2a divide by 2, divide by 2. A is 25 over 2, so that b is 25 over 2 by so b, since we have the value of a, we just substitute here. So get by negative 3, giving us negative 75 over 2 as the value of b. Any questions?
Which recommendation letter? I have to look. Oh.
Any questions? Okay, no questions. This was part A of this question. We got part B. Part B, find the equation of the normal line to the curve at the point 5, lane 5. Ours is to find the equation. Now, since we know that the tangent gradient is 1 over 4, and the gradient of the tangent multiplied by the gradient of the normal, we know it's equal to -1. So we're dealing with 1 over 4. Gradient of normal is -1, implying that gradient of normal is equal to -4. What does that mean? You have y minus y1 is equal to mx minus x1 as the equation of the line. So y minus y1 is lane 5 is equal to m is -4 x minus x1 is 5. So we get y is equal to negative 4x plus 20 plus then 5. So the line that we're looking for. Okay, let's go to question 3. Determine whether the functions below satisfy the hypothesis of the Rolle's theorem on the given interval. If they do, find the numbers C that satisfy the conclusion of the Rolle's theorem. What are the conditions? If f of x is a function let's put the conditions well. If f of x is defined and continuous, on a comma b and differentiable on an open interval a comma b with f prime of a equal to f prime of b, which is equal to 0, then there exists a number C in an open interval such that f prime of C is 0. A simple explanation of this theorem is that if you have a curve, for a curve to come out like this, it means that the function f, whose curve is this one, is defined and continuous and differentiable. If you pick some number A, you pick some number B. If, here not prime, these are direct. The middle ones here are direct, sorry. These are f of A is equal to f of B. So if f of A is 0, f of B is 0. It means that you are getting the numbers sitting on the x-axis. Now, then it makes sense by explanation. There will be a number here, C. There will be a number C, such that if you differentiate the function and substitute that C, you will get 0. Simply say there will be some line here. Okay, there will be a tangent line here. That will be horizontal, touching the curve. And you know that the horizontal line has a gradient which is 0. So that's the reason why. So this should be your thinking when you're talking about the Rolle's theorem. It's just about the first derivative being equal to 0, meaning that the gradient of that line is 0. So the line is horizontal line touching the curve of any nature. So we're assuming that whatever moves the function is not necessarily the f in relation to a, it's about the a and the derivative. So that when we go to the question, we pick a. If f of x is equal to 1 over 2x minus root x, and the interval is 0 to 4, we first check if this satisfies the Rolle's theorem. So what is f of 0? 1 over 2, 0 minus root 0. This is equal to 0. F of 4, you get 1 over 2, 4 minus root 4. This is 2 minus 2, which is 0. Hello.
Oh, on the graph, I wanted to ask a question. Since you said that continuous, the graph just flows just the way it is, then how can you show differentiability on the same graph?
Differentiability, you don't necessarily attach it to the graph itself. Or if you do, then you think about it in terms of limits. If you have a smooth graph, then your function is differentiable throughout the graph because you'll be getting the limit from either direction to be the same.
Can you kind of show the board?
Which one is the previous board? This one
The second.
or second?
Thank you.
So Natasha, using the graph, we cannot necessarily talk about differentiability here. But we know indirectly that the smoothness of a graph means differentiability. Okay. So we have f of 0, 0, f of 4, 0. Yeah?
No, I was saying thank you.
Oh, okay. So we've seen that f of 0 and f of 4 are equal and they're all zeros. And our function is defined on those points. Is it differentiable? Let's see. Half minus, you can write root x as x to the power half. So that when you differentiate, you get half x to the power negative half. This is the same as half minus 1 over 2 root x. It is differentiable. So if it is differentiable, then there's a number c that if you take in the derivative, we'll get 0. Meaning half minus 1 over 2 root c is equal to 0. If we multiply throughout by 2 root c, we're going to get root c minus 1 is equal to 0. So that root c is 1. And when we square, we get c is 1. But for sure, 1 is a number that lies in the interval 0, 4. So we have found such a number c, which lies in there, such that when you take it in the first derivative, you get 0. Questions now?
Can you repeat on the second part, sir?
So after you differentiate, then if it is differentiable and f of A is equal to f of B and you're getting 0, then the Rolle's theorem is satisfied. So its conclusion is that there's a number C that if you take that number in the first derivative, you get 0 as the output. So we got the first derivative where there is x, we substitute C and then start solving for that C. So we solve for the C, we get 1. Then you go and check if 1 is indeed in the interval AB. And you find that our interval is 0,4, so 1 lies in that interval.
Okay, thank you.
Okay. So this example represents the other pieces of this question. As far as Rolle's theorem is, no. We still have B and C. Very, very crucial. Okay, let's log out and come back quickly.